subfiles. Okay, because merge sort can be used as an external sorting method that sort files of huge size. Okay, that maybe the file is so big that it cannot be fully stored in the internal memory. Still, merge sort can be applied. Okay, so the terms being used in the notes, okay, following the original, the terms used by the original author, we use file and subfile rather than array and subarray. Okay. Now, for a given file of size n, okay, first of all, the method logically subdivide the file into n subfiles. Each of them has size 1. Okay, now when you have a file of size 1, okay, then the file is sorted. Okay, so you have n sorted subfiles. Okay. Then the merge sort procedure will go through several passes. Okay, like the case in the bubble sort. Okay, so in every pass, the merge sort algorithm will combine two adjacent subfiles, merge them to form a subfile. Okay, a sorted subfile of 2 times the size. Okay, so this is the idea. So in every pass, it will merge 2 adjacent subfiles to form a sorted subfile of long length. And so after one pass, the length of the subfile will be double. Okay, then it will go through another pass and now once again merge 2 adjacent subfiles to form a sorted subfile of longer length, and repeat the process until we come up with one single subfile. Then all the data are sorted in the desired order. Now this merge operation, merging 2 sorted array into one another sorted array, this operations we have seen it before in the first set of notes that when you merge 2 sorted array you only need to traverse the 2 array once from beginning to end and you keep 3 indexes ijk. So I is used to refer to an element in the first array A. J is an index you refers to an element in array B. So as long as the 2 indexes are within bound, now this is very important. Every time you use an index, you must ensure that the index value is valid. If the index value is not valid, then your computation may generate incorrect results. Now, here, as long as I and j are valid index, then we compare the value of ai with bj. If ai is less than or equal to bj, then we copy the value of ai to the results array C at position k. After that, I and k are increment. Otherwise, we copy the value from B to the result array C, and then we increment J and K. Now after this loop, stop, then either one of the 2 arrays A and B has been exhausted. The other array still have some numbers. Then we need to copy the remaining numbers. That is either from A or from B to the array C. After this copying, then we are done. Now this is the general procedure to merge 2 sorted array. Now having this in mind, then we can see how we can to implement the merge sort algorithm. Now the pseudocode for the merge sort algorithm, will be like this. So if we are going to sort an array X, we need to create some auxiliary array to perform the merging. So when we merge 2 array, we need a place to store the result, so we need to create an auxiliary array. And the size, the parameter size, okay, represent the size of a subfile. Okay, so we start from the case that the initial value of size is 1. Okay, so when initially we have every subfile of size 1. Okay, so as long as the size of the subfile is less than n, right? Okay, the full length of the array, then it means that we have 2 or more subfiles. Okay, so the sorting has not been completed. Okay, so we will go through the while loop. Okay. Now within the while loop, okay, we will merge 2 adjacent subfiles. Okay, from the array X and store the results to the auxiliary array. Okay. Every iteration in the for loop, the index I will be incremented by 2 because we are merging 2 subfiles. Okay, so after merging 2 subfiles, I will be advanced by 2. Okay. Now, the number of subfiles in some intermediate steps, it can be odd value. Okay, so if it is an odd value, then after this merging, after this inner for loop, we may be left with 1 single subfile. Okay, so we will copy the remaining data from X to the auxiliary array. After that, the size of the largest subfile will be doubled. Then we copy everything from the auxiliary array back to the array X again, go back to the loop to prepare for the next round of merging. Now this is the overall loop structure. Okay, then next we can make refinement. Okay, to this set of pseudocodes. Okay, to design the detailed program. Now to understand the programs, because in the program we have several local variables. Now the meaning of the variables are like this. Okay. So we have 2 pair of indexes, L1, U1, L2, and U2. Okay. Now L1 and U1 and L2 and U2 are used to reference the start and end of the 2 adjacent subfiles. Okay, in the array X that we are going to merge. Okay. And size. Okay, represent the length of a subfile. Then the indexes I, J, and K are used to reference the members of the array, the 2 subfiles in array X and also the positions in the auxiliary array where you are going to store the new numbers. Okay. So in the initial setup, so I is pointing to the first numbers in the left subfile, J is pointing to the first number in the second subfile, and K will be pointing to the position. Okay, if you are going to copy the data from X to auxiliary, where to put it in the results array. Now, going back to our pseudocode. Okay. Now we will initialize size to 1. Okay, and then within the loop we need to merge, okay, two adjacent subfiles. Okay, now first of all we need to set up, okay, the value of L1, U1, L2 and U2. Now, every time in every merge pass we start from the left hand side. Okay, so L1 will start from 0. Okay, and K, okay, also start from the left hand side, 0. Now, as long as L1 per size is less than n, so it means that now from this position, we have at least 2 subfiles. Okay, so if L1 per size is less than n, okay, so now the last index here is n minus 1, right? So if L1 per size is less than n, then we have at least 2 subfiles. Okay, then we need to do the merging. Okay. Now to do the merging, first of all we determine the starting index of the right hand side of file L2. So L2 is L1 per size. Okay. Then U1 will be L2 minus 1. Okay, because they are adjacent. Okay, U1 and then you have, okay, L2. Now for U2, okay, then it depends. Okay, depends on the actual size of the array. Okay. Now if L2 per size minus 1 is less than n, okay, then U2 will be equals to L2 per size minus 1. Otherwise, U2 will be set to n minus 1. Now, because of the right-hand side subfile, okay, maybe a full size subfile or it may be a smaller size. Okay. Now, considering the last segment, okay, now if this is L2, if L2 per size is beyond n, then U2 will be set to n minus 1. Otherwise, it will be, okay, this subfile is a full size subfile. Okay. Now, after setting up, okay, L1, U1, L2, U2, then the merge procedure, okay, will be the same as what we have seen before. Okay. Now then, to do the merging, okay, so for I start from L1, J start from L2, as long as I is less than or equals to U1, and J is less than or equals to U2, I have a typo here to be a lowercase u. And in every iteration, one value will be put into the auxiliary array, so K will be incremented by 1, okay, regardless of which value we take from the left-hand side subfile or the right-hand side subfile. Now if xi is less than or equal to xj, we take the value from xi and then I is increment. Otherwise, we take the value from xj and j is increment. Okay. Now when this loop terminates, we copy whatever remains in one of the subfiles to the auxiliary array. Okay. Now after that, okay, after we merge these two sublists, okay, into one sublist, then L1 will be updated to a new value. Okay, to U2 plus 1. Okay, so L1 will be updated to U2 plus 1. Then we come back to, okay, this internal while loop to see if we need to merge, okay, a pair of subfiles again. Okay, now we merge the next pair of subfiles, and then L1 will be, okay, updated to point to this position. Now, after this L1 precise is not less than n, okay, then it means that we are left with one subfile. Then we don't need to do the merging. Okay, then the inner while loop will be terminated. When we exit the inner loop, we copy whatever remains in the last subfile to the auxiliary array. Okay. Now, we have merged everything, okay, from the original array X into the auxiliary array. Now, in this example, we have 3 subfiles, okay, remains. Okay, so in the next round of merging, first we copy everything from auxiliary array back to the array X. Okay, so we copy everything from the auxiliary back to the array X. Okay, the size of a subfile is double. Okay, then we go back to the outer loop. Okay, so as long as size is less than n, we go through one more round of merging until size is greater than or equals to n. Then we are done. Now, some improvement to the implementation of merge sort can be possible. Okay, so one simple improvement is that for the last steps, we copy everything from the auxiliary array back to the array X. Okay, so it may consume considerable amount of time. We can save, okay, this effort by modifying the program such that in odd number of rounds, the merging will be from X to auxiliary. Then in the even number of rounds, the merging will be from auxiliary to X. Okay, so we save or we reduce 50% of the effort spent in copying the data. Now, but then the control of the algorithm, you need to put in some additional controls, or you need to make some general modifications. Okay, so you can rewrite the merge function, take it out, put it in another function that you pass to array. Okay, by passing the parameters, then you can control the movement of the data from one array to the other array. Now for the complexity. Okay. So first of all, the merge sort algorithms require additional memories. Okay, because the basic merging operation, we need another array to store the data. Okay, so it will have require more memory resources. Okay. Then the time to do one merge pass, is proportional to the length of the array, because when we are doing the merging, so basically we traverse the array once. So it will be order n times. Okay. Now in every merge pass, the length or the size of the sorted subfile is double. So the total number of merge paths that are required is equals to log n. So it doesn't matter. That's the best case, worst case, and average case will be the same for merge sort. Because no matter whether your array is already sorted, the merging will still go through log n passes. So the overall time complexity is order n log n. So the best case and worst case and average case they are the same for the merge sort method. but the overhead, the constant factor of merge sort will be higher than quick sort, simply because it needs to perform more data movement. So it moves data. For every data value, it will be moved log n times. So the constant factor of merge sort will be larger than the constant factor in the quick sort. So in general, merge sort can be slower than quick sort. Now, when we apply the sorting method to sort an array, we consider another properties of the sorting method is called the stable properties. Stable here doesn't mean that the program will crash or it will not crash. So a correct implementation of the algorithm is the program will not crash. When we say that a sorting method is stable, what we means is that if you have two records, say x and y, that two records contain equal key values in your input array. And x initially appears before y in the input. Now this is x, this is y. Now if you perform a sorting method based on the given key value, if in the output x is still placed in front of y, meaning that the relative order of x and y is always preserved, then the sorting algorithm is said to be stable. Now if you have two records, x and y, they have the same key, but after the sorting, the two records, the order can be interchanged. Then we say that the sorting method is not stable. Now, consider one situation like what we have done today. We want to sort an array of student records by major and then by name. Now suppose if your input array is already sorted by student name. Now you have a list of student records sorted by name. But the student can belongs to different majors. Now I want to reorganize the list such that it is sorted by major and then by name. Now, when you are sorting by major, you have multiple records in the array that have the same key, but they have some initial relative order. If your sorting method is stable, then your compare function in the sorting method only needs to compare the major, because in the output for two students belong to the same major, they have the initial relative order. So in the final output, for students in the same major, they are still ordered by name. So it means that if your array originally has certain ordering, and now you want to rearrange the order based on another attributes. If you want to preserve the initial relative order, then if you use a stable sorting method, your compare function only need to compare the new attributes. Now, which sorting methods are stable? Based on the four methods that we have discussed: bubble sort, insertion sort, quick sort, and merge sort. Now, bubble sort, you only interchange two records if they are out of order. If two records have the same key, you won't interchange their order. So basically, bubble sort is stable. Now, insertion sort is you consider the element on the right hand side and insert it into your sorted sublist. So if you have another record in front, they have the same key, you won't move the original elements to the right hand side to make room for insertion. So that's why insertion sort in the general implementation is stable. merge sort is also stable because, okay, by convention, when you are merging the left subfile with the right subfile, if you have equal key, you take the record from the left-hand side first. Okay. Now, however, quicksort is not a stable method because in the partitioning process, okay, we scan the subarray from left and right based on certain pivot value. Then we interchange these two records. Okay, when you interchange two records that are far away, they may jump over other records in between that may contain the same key value. Okay, so you cannot assure that in the output, okay, other records with the same key will preserve their original order. Okay, so quicksort is not a stable method. So what it means is that if you use quicksort to do sorting, then your compare function should be implemented to compare all the attributes based on the full ordering. Okay, you cannot say that now my array is already sorted by student name. If I want to sort the array again by major and then by name, I don't need to consider the name. No, you cannot do that. You need to specify your compare function to consider all the attributes in the full ordering. Okay. So it have certain implications on how you implement your compare function when you use different sorting methods. Okay. So if there is any question you want to ask about, okay, this aspect. Okay. Now, if you don't have questions, then we will move on to discuss another topic.